get started. So section 311 is titled, How Can I Solve the Equation? So we're going to be talking about strategies for solving equations. And by the end of this lesson, you will be able to solve a variety of equations and discuss different methods for solving, as evidenced by justifying your solutions. Today, you will have the opportunity to solve some challenging equations. As you work with your team, you will be challenged to use multiple approaches and to write clear explanations to show your understanding. So, the first one talks about solving graphically. All right, so one of the big ideas of chapter 2 was how to determine special points on the graph of a function. For example, you have used the equation of a parabola written in graphing form to locate its vertex without graphing. But what about the locations of other points on the parabola? Consider the graph of y equals x plus 3 squared minus 5 at the right. How many solutions does the equation of y equals x plus 3 squared minus 5 have? How is this shown on the graph at right? Anybody have some ideas about how many solutions there actually are to this graph?
Can you define solution?
Do you what?
Can you define solution?
Solutions. How many points would make that true? It is. It's infinite because you would have obviously your vertex, you could have some intercepts, but you could plug in any number and you would get a solution out. It would have infinitely many solutions. Kind of like a line. You could have many points, any infinite amount of points on a line. Same thing with a parabola because it doesn't have a beginning and an end. It has little arrows showing it goes on forever. You could plug in whole numbers, decimals, fractions. You would have infinite amount of points. Part B says the same question. Oh, no, it's written slightly, look like the same exact question. I'm like, what? How many solutions does the equation x plus 3 squared minus 5 equal 4 have? How is this shown on the graph? So it's written slightly different. Instead of having y in there and x in there, it just has x. So how many solutions is that going to have? 2 because of the square. So you would have not always just opposites, not just a positive and a negative, but frequently it could be a positive and a negative, or two different numbers, yes. It's probably, if they're the same, it could be 1, but because of the square, it's likely 2. You guys want to do it? Let's do it. So we're going to add 5 to both sides. Then we are left with x plus 3 squared equals 9. Then because we have a square here, the inverse operation of square is to square root. We're left with what's inside, which is the x plus 3, equal to the plus or minus 3, because the square root of 9 is 3. And this is how you get your two answers. You're going to subtract the 3. So you have x equals negative 3 plus 3, and you have x equals negative 3 minus 3. Negative 3 plus 3 is 0. And negative 3 minus 3 is negative 6. Every once in a while, they're the same, but in this case, they're not the same, obviously. So, let's see. At x equals 0, okay, so there's, x equals negative 6. Okay. So it says, how is this shown on the graph? At x equals 0, if we plug that back in, we're going to get this point up here. And at negative 6, is that where it's intersecting? No. It's going to be the same over here on the graph. So that's how it's shown on the graph. Use the graph to solve the equation of x plus 3 minus 5 equals 4. How did the graph help you solve the equation? Be sure to discuss this with your team. before recording your answers. So at 0, it looks like it's here's 0, so we come up here, it's like roughly right here. And at -6, it should be the same. It should be right about there. Roughly here and roughly here. Can you guys see that? That graph's so tiny. All right. Any questions on that? All right. Flip over to the top of page 2. Top of page 2 says, Algebraic Strategies. The graphs in problems 3-1 was useful to solve an equation like x plus 3 squared minus 5 equals 4. But what if you do not have an accurate graph? And what can you do when the solution is not on a grid point or is off your graph? In these cases, algebraic strategies are useful. The 3 main strategies that they're going to focus on are rewriting, looking inside, and undoing. So rewriting is using algebra to write a new equivalent equation that is easier to solve. Looking inside means reasoning about the value of the expression inside the function, or parentheses, or it could be under a radical, or it could be in absolute value bars. It's somehow contained, okay? And undoing, reversing or doing the opposite of an operation. For example, taking a square root to eliminating squaring, okay? These strategies and others will be useful throughout the rest of this course. Examine how each of these strategies can be used to solve the equation below by completing parts I and double I. So 1 and 2, your task, solve the equations below in at least 3 different ways. All right, so the first one I'm going to have you do it when you get to your groups of 4. But for now, we're going to look at the second one, which is, I want you to actually rewrite it. So scribble out the one that's there and put x plus 3 squared minus 5 equals -4. And we're going to use the strategy of rewriting. So for the rewriting, we're going to take the x plus 3 that's being squared, and we're going to rewrite it out. So instead of writing it as x plus 3 squared, we're going to write it as x plus 3 times x plus 3, and then bring down everything else. So we're going to take those 2 binomials, and we're going to FOIL them out. X times x gets you the x squared. The outside and the inside gets you the 6x, and the 3 times 3 gets you the 9. Okay? Then we're going to combine that -5 and move the 4 over, and we should get the 8 here. So 9 minus 5 is 4, but when we add this 4 back over, it gives us the 8. So now we've got a new trinomial, and it's set equal to 0, so now we can factor it. To factor x squared plus 6 plus 8, hopefully you see that's an easy one, because 8 is just 2 and 4, right? So x plus 4 is our first binomial, and x plus 2 is our second binomial. And then we say, what plugs in here to get 0? That would be -4. And what plugs in here to get 0? That would be -2. Okay? That's the strategy of rewriting. It's supposed to help you have one tool in your belt to help you solve, okay? The other 2 ways are called undoing and looking inside, okay? So for undoing, we have our equation that we started with back up here. X plus 3 squared minus 5 equals -4. So we're going to work backwards or do inverse operations until we get the x by itself. So we're going to add 5 to both sides, which gives us the x plus 3 squared equals 1. And then we're going to undo the squaring, which is square rooting. So we square root this side to get our x plus 3. That 3's kind of funky. We take the square root of 1, which is just 1, but you have to say plus or minus 1. That's how you get your 2 answers. And then just like we did on page 1, we set each of those equal to 1 and negative 1. So we get an answer of negative 2 and negative 4. Notice those answers is the same we got right there, right? Same answer, same answers. You should get the same answers, right? It's the same problem. So far, you've seen the same problem with 2 different ways. Okay? Is one better than the other? Or do you like one better than the other? Is one faster? Does one make more sense to you? Does one stick out like, hey, that's the way my teacher taught me, and so that's the way I like to do it? Okay? So there's all reasons for using different methods. This third method is called looking inside. Okay? So once we got this equation set equal to 1, if you add 5 to both sides, you get 1. So if we take the 1 and we subtract the 5 and set it equal to negative 4, we're going to have plus or minus 1 squared equals 1. So what number plus 3, which is basically what we did here, is going to be equal to plus and minus 1. So if we took negative 2 plus 3, we'd get positive 1. And if we took negative 4 plus 3 equals negative 1. The looking inside method is, I feel like it's when you get really good at these 2 methods and you can take this one a step beyond. Okay? So it's kind of like you're skipping this step. Okay? It's not my favorite, but you might like it. I kind of prefer the rewriting and the undoing. But does the looking inside work? Sure. Is it more helpful with other types of problems? Yes. And we'll see one of those in a minute. Okay. Jump down to question 3.3. Question 3.3 says Ernie decides to multiply both sides of the equation by 20 so that the equation becomes 5 times x minus 5 plus 8 equals 18. Which strategy does Ernie use, and how can you tell? So the original equation was x minus 5 over 4 plus 2/5 equals 9/10. Okay? So what did Ernie do? Ernie used rewriting, but most of you have probably heard of it as fraction busting, or looking at the denominators and seeing, what could I multiply all of them by to get rid of the denominators so that we're no longer looking at fractions. Okay, so 4 goes into 20 5 times. So we rewrite it as 5 times x minus 5. 5 goes into 20 4 times. So 4 times 2 is 8. And 10 goes into 20 twice. So 2 times 9 is 18. We completely rewrote the problem, right? So we call that rewriting. If you are used to calling it fraction busting, you can call it fraction busting. I'm totally fine with that. But why, or how do we know that Ernie used it? Why? Because it looks completely different. We went from this equation that had all these fractions in it to this equation that was a little more manageable, right? Okay, so we call that rewriting. Flip over to the top of page 3. We're just doing B and C at the top. Part B says L takes Ernie's equation and decides to subtract 8 from both sides to get 5 times x minus 5 equals 10. Which strategy did she use? She used undoing. She did inverse operations, right? And then part C, Eric looks at L's question and says, I can tell that x minus 5 must equal 2 because 5 times 2 is 10. Therefore, x minus 5 equals 2. and x must be